Today we talk about sampling. When you think of data science, what kind of data do you think of? A lot of us think of sources of big data, like administrative records and crawling the web. Today we'll talk about a very different kind of data, samples drawn from a population by a probability sampling method. Our learning goals for today are to talk about some of the key ideas in this way of collecting data, and then also at the end, which will be the next video here, we'll talk about accessing survey data online. So in the classroom, we're going to think about this question. Do you prefer to sit in the front or the back of the room? There are many ways we could see the proportion of students who prefer the front or prefer the back. One of those ways is full count enumeration. In full count enumeration, we find everyone in the target population. Here this is all the people taking our class. We ask them all the question, would you rather sit in the front or the back of the room? Another way to answer the question is by probability sampling. So let's take a probability sample of the class. Everyone in class will open R and run this line. R_unif generates a random uniform number between 0 and 1. N equals 1 tells it to generate one number. So for those in the class, we then said if the answer is less than 0.1, we want you to raise your hand to answer the question. Do you prefer the front or the back of the room? So while we started out by taking a full show of hands for the entire class, we're now taking a show of hands that has roughly 10% of the class selected randomly. If we wanted to visualize this, on the left we have full count enumeration. Every person in the classroom answers the question. On the right we have our probability sample. 10% of the people, chosen at random, answer the question. And of course, we would get different answers if we took different probability samples. Every time we run a probability sample, there's some randomness in who responds and the values they report because of who's chosen for the sample. So let's think about the advantages of each strategy. What's the advantage of full count enumeration? What's the advantage of a probability sample? We took a moment in class to talk about these advantages. One big advantage of full count enumeration is that you really get the answer. You get to talk to everyone and there's no uncertainty left. But an advantage of a probability sample is that it might be much cheaper than full count enumeration. It's less expensive to go talk to only 10% of the people in this case. So to conduct a probability sample, you need several things. You first need a target population. That's the set of people you want to study. Then you need a sampling frame. That's a list of all those people who comprise the target population. Then you need a sampling probability. So in this case, our sampling frame was people sitting in the classroom, and our sampling probability was 10% of those people selected at random. Then we need the people who we sampled. We'll call these people our sample. Then after that, we need the people who responded. In this example, I suspect that everyone who's sampled to answer the question will actually respond. But when you go sample people in an actual survey where you want them to answer lots of questions about their income, for instance, some of the people who sampled won't respond. Between these different things you need, there are various sources of error. One source of error is undercoverage. Sometimes our sampling frame doesn't include everyone in the target population. Maybe there are some folks who didn't come to class on this particular day. They're in the target population of people in class, but they weren't in the sampling frame from which we drew the sample. Another source of error is sampling variability. By random chance, we get 10% of the people in the class, and that may or may not be a 10% who have the same mean response as the population as a whole. Then we also have a source of error from non-response, if the people who responded are different in some way along this outcome than the people who didn't respond. When you put together all these sources of error, the answers we get by analyzing a particular sample may not be the same as the average value of the true response in the population. When you put these together, you can think in terms of the total survey error framework. This is a common framework for thinking about the quality of sample estimates. And this framework encompasses both statistical sources of uncertainty, like sampling variability, and other sources of error such as undercoverage and non-response.